What's up, you freaking geniuses? So in this video, I'm going to teach you how to solve exponential growth and decay word problems. All right, so let's start with a couple easy-ish ones to get us started. So the instructions right here say write a function that represents the situation. Okay, so let's start with A right here. So it says a pig with 3 butt cheeks is sold for $10,000 and his value increases 65% per year. All right, so extra bacon, makes sense. All right, so just in case you don't remember, the exponential growth and decay function is y is equal to a times 1 plus or minus r raised to the t, okay? Y over here is your final amount, a is your initial amount, r is your growth rate or decay rate, and t is the time in years. Okay, and whenever you're talking about exponential growth, you use the plus sign, and when you're talking about exponential decay, you use the minus sign, right? Easy enough. So again, with this problem over here, you can see that this pig over here got sold for $10,000 and his value is increasing, right? So that means we're using exponential growth here. So we're gonna have y is equal to a times 1 plus r raised to the t. Okay, he was initially sold for $10,000, all right? So that's gonna be our initial amount for a. And then it says that his value is increasing 65% per year. The percent is always gonna be your rate. So r over here, this is going to be where we put our 65%. So here we're going to have y is equal to, again, 10,000 is our initial amount, times 1 plus, and then 65%, we first have to turn that to a decimal. So that as a decimal is going to be 0.65, right? And then that's raised to the t. And then I can simplify this a little bit more. So we're going to say that y is equal to 10,000 and 1 plus 0.65, that's just equal to 1.65. And then again, that's raised to the t, okay? So this would be your final answer right here. This is the function. All right, so hopefully not too bad. Let's try one more kind of easy-ish one. All right, so this one says, a picture of Yo Mama valued at $420 decreases in value 9.5% each year. Tell Yo Mama I'm sorry, all right? But at least it has sentimental value, right? So in this problem, you can see here, this is the keyword, right? Decreases. So whenever you see decreases, that just means exponential decay, right? So we're gonna use y is equal to a times 1 minus r raised to the t, okay? So the initial value, right? So it's a picture of Yo Mama valued at $420. So that was the initial value. So we're gonna plug in 420 right there. And then it says, decreases in value 9.5%. So again, the percent is our rate, right? But we have to turn this into a decimal. So to turn any percent into a decimal, just divide this number by 100. Okay, so 9.5 divided by 100 is equal to, just move the decimal 2 times to the left, like that. So it'd be 0.095, right? So then here, right here, we're gonna plug in 0.095, right? Let's write it out. So we have y is equal to 420 times 1 minus 0.095 raised to the t, all right? And then lastly, again, we just have to simplify what's here in our parentheses. So then this is going to be equal to 420, and then 1 minus 0.095, you can plug it into your calculator if you want, is 0.905, right? And then, again, it's raised to the t. All right, so this would be your exponential decay function for this problem. Okay, here's the next problem. So this one says the inaugural attendance of an illegal underground petting zoo is 15,000. The attendance Y increases by 6.9%, nice, every year, okay? So then the first part of this problem is saying, write an exponential growth function that represents the attendance after t years, right? So this is gonna be the same thing we just did in the last problem, okay? So it says exponential growth, right? So that means we're gonna use the Y is equal to a times 1 plus r raised to the t, okay? So let's see what we can fill out here. Okay, so the inaugural attendance, so the starting attendance, the initial attendance was 15,000, right? So we're gonna plug in 15,000 for our initial attendance right there. And then it says it increases 6.9% every year, okay? So 6.9% is our rate, right? So 6.9% as a decimal is gonna be 0.069. right? So again, and that's our rate, right? So then we can put that y is equal to 15,000 times 1 plus 0.069 raised to the t. Okay, and then just simplifying what's here in our parentheses, it's going to be, we're going to say y is equal to 15,000 times 1 plus 0.069 is just 1.069. Nice, raised to the t. Okay, so then this would be our function right here. Boom, okay. Now, what's the second part say? So this says, how many people will attend the festival in the 4th year? Round to the nearest 100. Okay, so we're going to use the function that we just came up with, right? Y is equal to 15,000 times 1.069 raised to the t, but we have to plug in something for t now, okay? And the problem is asking us for the 4th year, okay? So remember, t, our time, is always in years. So if it's asking for the 4th year, we're just going to plug in a 4 right there, okay? And then if we evaluate this, this is going to be y is equal to 15,000, okay? And then 1.069 raised to the 4th power, that's approximately 1.31. And then 15,000 times 1.31, this is approximately 19,588, right? But remember, it's asking us to round to the nearest hundredth, right? The hundredths place. So we're going to round this up to 19,600. Okay, so that's about what the attendance should be at this illegal underground petting zoo after the 4th year. All right, so these problems have been a little bit silly. So let's put a pause on that and make these a little bit more serious. All right, here's the next one. So it says you purchased a haunted portrait of a dead clown in 2020 for $25,000. That sounds pretty serious to me. The value decreases, thank God, by 14% annually. Find the value of the portrait in 2025. All right, so this is a very serious problem, as you can tell, right? Because we're talking about a dead clown. I'm going to use red on purpose, right? Dead clown, sad tears, right? So this portrait, you bought it in 2020 for $25,000. And then it says the value decreased, right? So that means we're talking about exponential decay. So we're going to say y is equal to a times 1 minus r raised to the t, okay? So let's plug some information in. So what was our initial amount? Well, initially, you bought it in 2020 for $25,000, right? So we're going to say y is equal to 25,000, like that, times 1 minus, and then what's our rate? Well, the rate is 14%. All right, so 14%, again, as a decimal, is equal to 0.14. So we're going to plug in 0.14 right there. And then what are we going to plug in for t? Well, initially you bought it in 2020, and we want to know what the price is, right? It says find the value of the portrait in 2025. So that's a difference of 5 years, right? So that means we're going to plug in a 5 for t right there. Okay, so now we're going to have y is equal to 25,000. And then 1 minus 0.14 is equal to 0.86, right? And then we're raising that to the 5th power. Okay, so then simplifying this, we're going to have y is equal to 25,000 times, and then 0.86 raised to the 5th power, that's approximately 0.47. Okay, so then 25,000 times 0.47, that's approximately $11,760. And then we'll just round to the whole dollar. Okay, so we'll just leave it right there. So the value after 5 years of this creepy dead clown portrait is $11,760. Okay, now let's jump to part A right here. So follow-up question. This one says, write the function if the value decreased 14% semi-annually. Okay, so originally it says the value decreased 14% annually. Now we're saying it's decreasing 14% semi-annually. And when you see semi-annually, that just means twice a year or every 6 months. Okay, every 6 months, if you want to think of it that way, whichever way. Okay, so how would that change our function? Okay, so remember this was our function right here, right? Y is equal to 25,000 times 0.86 raised to the t, right? And then we plugged in a 5 for t right there, okay? But in this case, since we're not talking about every year, we're talking about every 6 months, our t is going to change. Okay, how is it going to change? Well, remember t you want it in years, but this is obviously not in years, right? It's saying every 6 months, okay? So how many 6-month periods are there in a year? Well, there's 2, right? There's 2 6-month periods in a single year. So then instead of just having t up here, we would actually have 2 times t. So you could just write it as 2t like that, okay? What if it was saying that we decreased 14% quarterly? Well, what would the function be in that case? Well, in this case, y is equal to 25,000, right, times 0.86. And then how would our t change? Well, it's saying it's decreasing quarterly, okay? So quarterly means every, I'll write it out, so every 3 months. Okay, how many 3-month periods are there in a year? Well, there's 4, right? So then here, since there's 4 of those, we would say 4t, or 4 times t, okay? Now, what if it said decrease 14% monthly? Well, again, we could write our function, right? So it'd be y is equal to 25,000 times 0.86. And then how would our t change in this case? Okay, well, how many months are in a year? There's 12 months in a year, right? So then we would write this as 12 times t, or 12t. Okay, so here it says a man named Ashley with a peanut allergy bought a house in 2008, right? So he bought a house in 2008. The value of the house increases 6% every year. If the price of the house is $397,000 in 2022, how much was the house worth in 2008? Okay, so let's figure some stuff out. So this dude, Ashley, bought a house in 2008. The value of the house has been increasing. Okay, so that means we're talking about growth, right? 6% every year. Okay, now it says the price of the house is $397,000 in 2022. Okay, so this is the current price. And then we're trying to figure out how much the house was worth back in 2008, or how much he bought it for originally. Okay, well, first of all, we're talking about exponential growth, right? Because it's talking about increasing. So let's start there. So we're going to have y is equal to a times 1 plus r raised to the t. Okay, let's try and fill some stuff out. So what's our initial amount? How much was the house initially? Well, we're trying to figure out what it was initially back in 2008, right? So we don't know the initial price right now, okay? So we're going to skip on that one right now. Do we know our rate? Yes, we do, right? It's 6%, right? So 6% is equal to 0.06 as a decimal, okay? And then the other thing that we know is our current or final price, which is y. Okay, so that's where this $397,000 go. So that's going to go right there. Okay, so then we're going to say that 397,000 is equal to a times 1 plus our rate, which again is 0.06, raised to the t. Okay, what's our t in this case? Well, he originally bought it in 2008, and then we're saying that the price in 2022 is this, right? So the difference right here is 14 years, right? So that's what we're going to plug in right here, 14. Okay, and then we can simplify this a little bit. So 397,000 is equal to a times 1.06 raised to the 14th power. Okay, now 1.06 raised to the 14th power, that's approximately 2.26. And then we're multiplying that by a, right? And then again, we're saying that's equal to 397,000. Okay, now to solve for a over here, we're going to get rid of the 2.26, and we're going to do that by dividing both sides by 2.26, right? Because what we do to one side, we do to the other. All right, so then on this side, these cancel out. So then on this side, we're just left with a. So then we get a is equal to 397,000 divided by 2.26, and that's approximately 175,590, and we're going to round to the nearest dollar, 94. Okay, so then this is telling us that the initial value of the house, how much Ashley bought his house for back in 2008, was $175,594. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.